Hello, welcome to this webinar today with Lucas. We're going to talk today about AI manufacturing and how combining AI and automation in manufacturing can really put an edge, like it's the next step for improving the quality of manufacturing goods. Hello, Lucas, welcome. Thanks for joining us.
Hi, Mark. Thanks for the invitation.
Yeah. That's everything I prepared. Why don't you tell us a bit about the technology that you are representing, or like the one that we integrate and that we are helping automate?
Yeah. So what we have is a smart AI camera, which is basically the size of a big smartphone.
Okay.
And the idea is that you have everything on that camera.
Okay.
Meaning that you obviously have the camera to take the images, but you also have the full computer and all of the processing needed to train the model and run the model on the camera.
Okay.
So you don't depend on anything else. You don't need an external software or a powerful computer. You have everything in the camera, which is very handy. You can put it everywhere on the line you want. You don't need to connect it to the internet or to connect it to things if you don't need to.
Okay, that's right. And it's basically plug and play camera, right? It's like
it's basically a plug and play camera.
Okay.
Yeah, you have like this powerful NVIDIA chip where everything is actually optimized and made to run speed and energy efficient. And together there's the camera integrated, and we have all of the hardware all together.
Okay.
That's working like this.
How long have you been actually working with this camera? It's a pretty new product, right? So it's like really.
So I think the first version of that camera came out maybe a year and a half ago.
Okay.
And us, we're working with it since a year now.
Okay. I'm just curious, like from all the demos and applications that you've made, at what point did you have the wow moment, saying like, oh wow, this can really help?
For me, to make a visual quality inspection with AI solution like worth it, there are two things. One thing is the easiness of the integration. So easy it is to actually connect it with the robot, to connect it with the PLC on the line, to actually like make use of what the camera is inspecting. And the second part is really like how, as an operator or someone from the factory, can I teach that system what is my quality standard, what are the defects?
Yeah.
And I mean, I've been working a lot already with this problematic, building some software, building some machine to do it. And when I came to work with this camera, which is built by Overview, this company in the US, I really found like kind of the same philosophy about how the camera should be taught by the people on the factory floor. And you really see, I mean, we were playing together with it and doing some demo, and I think it's quite impressive to see that once you manage to put like the operator or the person using the camera in the driver's seat, and that they understand, okay, I just need to show to the camera what's the defect, and then the camera is going to learn from it, then all of the AI complexity is gone. Because the person just need to do the job that they're used to put the knowledge that they have in their head inside of the camera for it to be able to do it.
Okay, but from all the applications that you've seen, which one actually specifically say like, okay, we tried it here, and then I was like, okay, wow, this really works well.
I mean, the leather one that we did is, I think, a very, very good example. The one we do a lot in Switzerland is on the metal surfaces.
Okay.
So specifically when you have like very shiny surface, and you're looking for like scratch of whatever dimension or even like surface aspect, I think deep learning or AI works very well with this, because it's very difficult with traditional computer vision to define a specific set of rules that would basically cover all of those type of use cases.
Right, because you studied computer vision, right? So and we are like, well, I would say young, but not that young anymore. So we studied pre GPT, transformers, architectures, and then the AI was like, I mean, there were a lot of applications, but for vision there were a lot of things that were working very well. But there's also at least for me, probably you also, we studied a lot of more of the traditional algorithms that were more, I would say, rule-based, right? Saying, okay, if you see an edge here and then you detect some change of color, or some and then you measure the pixels and all that, like, so a bit more in the programming we would say hard-coded, right? So you used to work on that, right? And now you've seen this. Do you think all computer vision applications are pretty much obsolete?
No. I think you still have use cases where using, like say, traditional computer vision method is still better than using AI.
Why?
Specifically in terms of, for example, measurements, or if you have like something so simple that you look at something, it's like, if this pixel is black, then it's good. If this pixel is white, then it's bad. Then it's like, why going all the fuss to use AI if it's so simple and it actually covers the whole cases? There are still some applications that are so simple that you don't need to use AI for it.
And it doesn't make sense.
To
you use it in those cases, right?
Yeah,
it's like you're like it's an overkill of the technology. It's like, yeah, sure, maybe you could do it with AI, but it's like it's not worth it.
I think the way I like to explain the difference between the traditional computer vision and AI solution is that, as you say, for the traditional computer vision, you as like the human, you need to define the set of rules that the computer is going to follow to say if basically this is a pass or fail. For the AI, what's going to happen is that you're going to give the example, and then that's the AI job to actually define the set of rules. And because they're a computer, they're going to have a lot more set of rules that they can actually test and refine to get something that is a bit more generalizable. But I think in a way, if you're like so lazy or like you really have no clue about the rules, then even if there's a simple thing, you could use AI to just have the things defined. But I think it's be an overkill. And in most applications, like, if you're a bit in that topic, I think you would prefer to do it like straightforward. I'd use this one thing and that's done. I think AI is really more today, it's opening a lot of use cases that before had actually no solutions.
Yeah.
And I think that's
or that the complexity of the algorithm that you would need to do to be there would require so much development and research for that particular project that it would be too expensive to actually be worth it, right? So,
and I think also it's keeping this set of rule kind of updated, because I mean, like, production lines can run across multiple years. A lot of things can change. Maybe like the raw materials, even like the factory around. Like if you don't control fully the lighting and things, lights can change. And if you define a specific set of rules, then this might change. You need to change your whole algorithm. It's very difficult to troubleshoot what type of parameters you need to change.
Yeah, maintainability in the long term, that's the key. And here I will talk something that is not AI, but it's about our software, because this is how I see our software also right now. Because what we see in the traditional manufacturing lines up until now is that you have a line and then each robot is hard-coded, right? So it's like you need a programmer, a specialist on that specific robot brand, like whatever brand it is, and it's hard-coded. The PLC that controls the turntables, the line in, line out, all the things are also hard-coded. So you need a lot of programmers. It's very specific knowledge. It's very nice if you have it running. It runs. But once you want to touch something,
don't touch it.
it's a pain in the ass. And so I see that parallelism between that and computer vision, as in like, yeah, so it works. There are some cases where you cannot do it. It's too complex. But if it would require a lot of hard coding, a lot of specialist knowledge. And right now, I think where we are now is like, okay, with our software, with the automation software, we just remove this complexity, right? So we say like, okay, now if you want to change a robot program, if you want to adjust something, it's a visual thing. It's very simple, it's understandable, right? It's not code, it's not. And I see the same thing.
Wires.
Exactly, and I see that this AI camera is doing the same step that we're doing with the computer vision, because computer vision has existed for a long time, and there are cases that are working in the industry to detect stuff, but they were just really very hard to do, very expensive, and very hard to maintain. They had these three things, and I think this AI camera is doing the same step. It's making like, okay, now it's a very easy interface. It's human understandable, because you see the pictures, you understand. You're not coding. It's no code, right? So it's the same concept that we do for the automation is for the computer vision problems. I think it's really it's a game changer on that. I think, and the nice thing here is that that's our collaboration, right? It's like we can do both, you know. So
Yes.
we can do your automation and your line smart and easy to maintain, and add the computer vision that is also smart and easy to maintain together. It's like it's a super powerful.
Maybe I can talk from the computer vision side. I mean, like the technology, specifically also in deep learning, now it's going to be almost like 10 years that actually the use case that we're now doing in manufacturing kind of were already possible to solve it technologically.
Yeah.
But like it took kind of like 10 years to bring that technology to manufacturing and to make it usable in that specific industry. And here I link with you on this is that at the end it's really not about the capabilities of AI, it's really about this integration and this ease of use for the people that are working there.
Right. Yeah.
And this is where the combination of your software for the automation and our system for the visual quality inspection actually are a really good match to unlock all of those like those applications.
Yeah, I agree. But let's talk about because there's one thing here, because it seems like we are like AI evangelists here, but we actually work on it and test it. And there's also some things, right? And I see that in contrast with computer vision. For example, if the example that you said, that when it's very simple, the computer vision is more, it really depends on the application, but in a lot of times it is definitely more explainable, and it can be more reliable, right? So AI can sometimes be a bit more noisy, and even if more noisy, it's less explainable, right? Because it's like, okay, it's giving this. I don't really know why, you know, because it's kind of a black box, which is the difficult thing about AI right now, you know.
Yeah, I mean, there are a lot of progress that are doing this. I think I've shown you on the camera, you have this heat map that show you kind of the focus area.
Yeah, you can see it's looking at the wrong place.
Exactly. So you have a lot of, say, cues like this that helps you understand what's happening in the background. And I think that's also very important for people to get used to work with those tools and to not be afraid. It's not a black box that's going to do things that you don't understand. There's actually like logic behind it in a way. Very complex logic, but it's not something out of the sky. For us as well, when we were going into computer vision, visual quality inspection, one main thing that we were actually thinking about is like, if we would be building a factory line in space where there are no humans, how would we do the automation and the quality inspection at the end? And that was also kind of a North Star that we used when we were actually developing a system, trying to understand, okay, if we go to the extreme, could be also underwater, like, I don't know, you have like something building things underwater where no humans can be. So you cannot cheat, like we say sometimes you'll be doing factories that where you have this one little thingy process, this one little that where you still have a human touching it for whatever reason, but here you cannot. And I think that's kind of also changed the way you think about the problems.
We have enough to have factories that are like very lightly supervised, right? Maybe you have one or two people checking a whole factory. Right now, what's happening right now is like you have hundreds of people, or like maybe even more, because you have hundreds there, and then those people need the knowledge of the other 100 people, because it's very specific knowledge. So what I see is like technologically, from the technologies that we have, without counting AI actually brings, I think it's, and that's why we are excited, and we're going to show it in a bit, like what we can do, because it's another step. But even without AI, we can bring the factory so much farther into the real automation, meaning that you don't need humans to actually manufacture things, right? So right now, we look like 100 years ago, you needed a person actually doing everything. We've been taking steps and reducing the amount of humans that need to be bind, into the factory, right? So we're reducing that. I think with our software and the current technologies, without counting AI, we can do a very big step, and that's what we're doing. That's our vision, right? It's a software. It's so simple to use. It's so universal. It's a platform, it just allows any operator to say like, I'm gonna now maintain 10 lines because the complexity is reduced so much, you know, that I don't need one for each one because of these edge cases. No. I have one and maybe I can do 10, 20 and more and more and more right now. That's the steps that we're doing.
But there's another topic that is, I think, quite interesting and important for Switzerland, where we're from, is really they call the flexible automation. So we talked a bit about like, making easier to automate, but there are also like, manufacturing where you do very small batches of a lot of different parts. I mean, I think about aerospace, watchmaking, medical, and what I've seen is that in those ones you usually have very high resistance or barrier for automation, because as you say, like the solution before were very expensive.
Yeah.
And you build it once and you cannot adapt it to the rest of your production.
Because all the solutions, all the manufacturing lines are ad hoc, right? They're just hard coded. It's like no. It's like the algorithm for this robot is this. There's no and modifying that is just very complex. You know, this is the big problem. I think like when we start reducing, the amount of people and knowledge, specific knowledge needed to actually operate one line. And I think the direction is like, okay, wow, if a person can really do a line, then that same person can do the modifications to do small batches, right? So because, okay, the piece A is doing this machine, right? And piece B is doing this machine instead of the other one. And then here it's different, right? So it just forks, right? Yeah. And then I'm able to do it because I have a control software, a platform, a universal software that is able to actually, with a few clicks, saying now, okay, you produce 10 of these. Yeah, I have all the information. I see it. I produce 10 of this. That's it. Okay, go to the next one, right? But the flexible manufacturing can only be really achieved if the iteration process, if the modification process, if the control, if everything is very easy to do.
Yes.
Because if you need to, okay, I want to change, like if you think about your house and your plumbing, right?
Yeah.
Like if every time you want to change some plumbing, you need to call a guy. He needs to come. He'll say, fuck, no, I forgot this thing. Let me come back tomorrow. This is horrible, right? It's the classical thing in your house.
I have to ask you, are you building a house? Because every example you gave me for the last 2 days was always about building a house, changing the plumbing.
No, I don't.
They're a super good example, actually.
I don't have a budget for that. No, but I do like a lot. So on my free time, I like to do a lot of do-it-yourself things in my home, and I'm a bit obsessed on automating the things that I have to do in my home. Right? I want to minimize the things that I want to do. So the piping thing is because I'm currently trying to remote control each thing individually, so I don't have to go manually turn on and things, which is a perfect example for the factory. In the factories, there's guys like, okay, now we change the process. It's like there's a guy that needs to go there, needs to understand how the machine works. Like, okay, let me turn this off. Let me change these cables. It's like, Jesus Christ, it's the 21st century. We have the technologies, we're just not using them properly. We don't have the platform to use it. Like that's what we want to provide. I mean, that's where we're going. Yeah. So basically, the example of the manufacturing right now is just like what happens in your home. It's like. Hey, I want to change this to make my life easier, or because the process changed, because I need to manufacture a bit different, or because we detected this and we need to change. Okay, let me call the guy that knows how to do it. This guy, there's only a few guys, they need to come, they need special pieces, they need everything, takes time, they come back, and so any manufacturing company owns the thing, but it doesn't really own the thing, because whenever they want to change something, they depend on external persons, right? Like what we do, like what we are proposing with our software is like, okay, let's make actually the manufacturing line so easy to maintain and to modify up to a certain extent. Of course, depends on how deep you want to go, but for 90% of the cases or more, it's like just small modifications that you can do. Let's make that so easy, which is, with current technologies, 100% possible. let's make that so that the manufacturing company actually owns the manufacturing line and actually is able to do it, right? And I think this is really the game changer. And if we talk about technologies, right? So the one piece of technology that can really put the extra edge, the icing on the cake, to make it even simpler is the AI camera. And we've been testing it here in Elevate Dynamics because, I mean, technologically we are skeptical, we like to see things work before we tell our customers. And here I can show you an example of some fake leather that we tested. We trained with some other samples, and then we did some paint on it, some creases on it. We damaged it, we cut it a bit, with very, actually, I don't know if you're gonna see it, with barely visible defects, right? And this is something that with computer vision, I don't think this is possible to detect these things.
That would be quite tricky.
It would be very tricky. And if I come to you 5 years ago and I tell you, okay, can you detect defects on this sheet? What would be the budget that you would tell me and time that you would need to develop this?
Probably say it's going to take us 3 months, and actually it's still not going to be very robust at the end.
3 months? Okay. I would have said even more, because some of these things are like, well, I mean, you already said, like, maybe the paint is the easier.
I don't know, if you go in the details for this, you define like one specific color. We have like a perfect control of the lighting and everything. Like the painting, you could most probably detect it with kind of a big accuracy. I think we've seen with the scratches that would be a bit more difficult and challenging, specifically for the scratches that are really kind of saying, following the leather, like the one that are teared off where you have really parts that coming out. We have like a bit of a different patterns that created by the shadow. So maybe with some different lighting, we could get actually those shadows. The crisp, I guess we could get it with a different lighting. But here, like, I think all the complexity would be in like, playing with all of the lighting and everything just to get those things out. And here we had like 3 little samples. We put like paints, took like, I don't remember, like 15 pictures. Trained the model for like 10 minutes, and then boom, we had something that was working on those defects that it has never seen before on a very complex structure that is like the leather.
Yeah, and it worked very well. It worked very well. I was very surprised that it was able to do that, because the leather has all these creases, right, that are random. So it's like, you can confuse them with the cut. You say, okay, is this a cut or not? And you can see it. But no, it's able to figure out, no, actually the cuts and the defects are actually, and it took us like, as you said, like maybe 1 hour of work, instead of 3 months that he suggested, because he's a specialist, For me, it would be probably a year to do that, or even more if I can ever reach it.
I'm usually pretty optimistic, that's true.
And as an optimist, so you imagine the radical change this implies on the kind of problems that we can solve now. The cost reduction of this is insane.
And specifically also the performance, because even if you have a human that could detect this,
I don't see them sometimes. Depends on the lighting. There's some of them I don't see them. When we put it in the camera, I'm like, wait, is it? Yeah, okay, here it's detecting this thing, and it actually is a defect. Because the camera, of course, has like special like LEDs with that project a pattern that have a strong light, and then they help in detecting these defects.
Yeah, that's also one of the advantages of these cameras, that you have the lighting integrated into it. And you can play with the lighting as well, and the camera itself can play with the lighting to remove some of the reflect.
Yeah.
So it's the idea is to have something as simple as possible. And as you described it, like usually when I go to a customer, I tell them like, I'm bringing you a tool. Like, I don't want you to call me back because you need to change something. Like, you need to be able to manage this by yourself.
Yeah, this is the same paradigm that we want to use. We like, honestly, I want the customer, I want the manufacturing lines to own it. To say, no, this is just, I will be there to support you, to train you, to give you the knowledge if you need it. But if you need to modify it, you don't depend on me. And your reaction time is much faster. And then we can start talking about, okay, do we do flexible manufacturing lines? Because then in this case, if I do a change, it will take me 20 minutes. It will not take me 2 weeks, because the guy needs to come. It's very busy. Blah 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 blah. And this is really like giving the autonomy to the manufacturing lines to actually modify their process and adapt it and change the defects. And for example, we also tried like, if you have a new defect, okay, I already have the word, let's add a bit more images to see like, okay, now let's try to detect, we started with the paint and then let's start to detect the creases, okay, and then I was like, okay, let's try to break it a bit, like pushing the technology to the limits. And I've been very surprised that it's been capable of doing most of it. Even some of them are like, okay, let's do a very small, let's do a small point here, a very small point here, and it was able to detect it. It was able to detect it. And here is one thing that I wanna talk about is that there is one thing that it's limiting, right? And this is the lens and the pixels that you can get of the picture, right? So depending on the size of the defect that you want to get, you will need to be with a different lens, a different focal point, right? And you'll need to be closer or farther from the part, right? So if from where the people can see us, a camera is not going to be able to detect it, right? So you need to go close, you need to go to be able to detect these defects. Same as a human. I don't think the cameraman is able to really detect this. Maybe the pain, yes, because it's really apparent. But no, he's saying no. But the thing here is that, okay, so it's very good technology, but it's missing one part, right? And this is the part where our collaboration is very strong, and it's the robot, right? Because if you cannot do it from there here, the whole thing, what we can do is like, okay, let's take a robot, let's automate it, and let's make the robot go through the part and take pictures and slowly figure out exactly where the defects are, right? And this is where our collaboration is like, okay, if I want to do the whole couch and detect defects, there's no camera right now, it's not possible to detect the small defects, right? Because there's a ratio of pixels density that you can do.
I think the reason is like, most of the things that are produced in any case, they are 3D objects. So you cannot just put the camera and let it slide. Like you need a way to move around it. When you look at actually quality inspectors,
like this couch, you have to do this surface. This has an angle like this. This one is like this. Like here, you're here. You wanna see here. So there's no single position. You would need like 100 cameras to do all the things, to do all the patches, and then still you would be limited by the size of the thing that you can detect, right?
Yeah, here together with the robot and the camera, you can go everywhere as close as you want. And high repeatability. You could scale the system as you need. So I think for me that's really where you really unlock like so many more use cases of visual quality inspection, where you still needed a human, not because the technology was not good enough to detect the defect, but because you need someone to actually turn around and move it. And in here, I'm no robot expert, but it's true that
you don't need to be. I'm neither. But we have a software that made it so easy that I was able. I don't know about the robot so much. I just know it's like a video game. I can play video games. I can program in our software. Yeah, but that's basically the baseline.
That's the experience I had. For me, like it's always when I have a part, maybe customers wants to see different angles, and you have to kind of like move the cameras around, test it, and like, okay, I could just take your software, say I want the camera here, 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 and that was it.
Yeah.
Like I had the exact picture I needed it. I know that if I put the same part at the same place all the time, I will always get the same picture, and I can do always the same inspection. So.
And the nice thing is that the repeatability of the robot really helps AI because it removes a lot of the noise, right? So that if the part is positioned like that, and then the AI is a bit harder to train because you need more examples. But in this case, in the manufacturing, it's so deterministic. You know how the part is going to be, you know where the robot is going to go, that you always get the same picture. You really can focus on actually, okay, no, not aligning or anything. You can really focus like, is there a defect there or not, So you remove a lot of the complexity of the AI, and then the AI really performs well.
No, I think the accessibility of manufacturing robots, together with AI and like software to program those robots in a very easy way, it's definitely going to change a lot of things.
Yeah, awesome. Um, I think that's it for today. I think I would like to keep talking someday. I think we're gonna do probably another
Part
one,
two.
a part two. But if anyone watching us has any questions, we'll be more than happy to help answer those.
Yeah, happy to answer any questions.
Thanks for seeing us.
Thank you, guys. So I hope you enjoyed the webinar and the presentation.
I think now if you guys have any questions, we'll be happy to help you with any doubts or any clarifications, anything that you want to know about the AI camera, about our software, AI in general, whatever. If you guys want, you can write it in the chat also. We can check it. If you have questions, you can write them down there and we can answer them.
Technical questions or like specific things about specifically like 11 Dynamics software or the AI cameras. I don't know if you joined this this webinar with some specific ideas of applications, and you want to quickly know if it's actually something feasible or possible. That's also something we can answer here. Because Marc only showed the example with the fake leather, but for example, specifically in Switzerland, we have a lot of application on metal shiny surfaces. So there are some topics that we didn't cover in the webinar, but we also work together with 11 Dynamics to do inspection of metal surfaces that are very reflective. So integrated in the camera, there are like some photometric capabilities in order to remove the reflects. Then you can move the camera around the parts if it's too complex to detect different scratches. So yeah, so I'm answering the question from Joao. So just reading it here. Can these solutions detect defects in sheet metal parts like a side panel or a car door? So I'm guessing here you mean about scratches or potential dents. So this is definitely what I was just like talking about. You can detect those ones, and then to follow up on the webinar and what Marc was saying in the video. Depending on the size of the defect that you want to actually detect, you might need to be quite close to the parts. So you cannot get in one picture everything, but thanks to the 11 dynamic softwares, you can actually easily have a robot moving all around the parts to detect all of the different defects. I hope this answered the question, Joao. I don't know if you want to add something, Marc.
No, yeah, that's it. I mean, at the end, the resolution of the camera determines how small, and the resolution multiplied by distance determines the size of the defect. So if you have very big defects, like I don't know, so you had some hole that's supposed to be there and it's not there, and it's like this, it's going to be very easy. You can do it far away. If it's like scratches, which are usually smaller, then you would need to go over the surface with a few pictures. In general, we show the leather because it shows also the complexity because it has this random pattern, right? Which is usually very complex with computer vision, and AI is able to do it very easily. For sheet metal is easier because they're usually smoother. And then scratches are like scratches, things missing, dents, works just fine also. I
Moving on
think
to the question of Mario.
yeah. So I can read
I
it.
can read
After
it
the
as well.
inspection, made with various systems like 3D measurements, visual inspection, how a report can be created and data may be shared with IT interfaces. Okay, so when we talk about automation, the nice thing about the software that we offer for automation is that we centralize all the data, like all the triggers, all the data information, and then we can make a report or we can upload it to the internal servers of the company. So, for example, we have applications where we're using a robot, and the robot has mounted a traditional, or let's say traditional optical scanner, and then like on one side and on the other side we have the A camera. So like we're scanning the part to do the dimensional metrology, and then we flip it, and then with the robot we take the pictures for the additional defects. It does our software for automation for Dynamics centralizes all the data, so it triggers the scanner, it triggers the robot, it triggers the AI camera, it coordinates everything, it gathers all the results into one software, into IDAS. You can visualize it there, and you can also make a report or export the data or export the results to your database. It's also possible to connect it to other internal services. So we adapt to the factory. So that's the nice thing, because we coordinate and gather all the data, we can very easily put it where you want it to be, like in the internal service, or like in a shared drive where we upload all the reports and the data and the pictures also. So you have one centralized result of the quality control. You don't have to deal with two different interfaces, the AI camera, the 3D scanner. It's like everything is one interface, everybody is one report, one result. Yeah, so Joao verified he was talking about small dents and scratches. Yeah, those that you don't see till the part gets painted. Yes, those are like those are detectable. As said, the only limiting factor, maybe Lucas, you can explain a bit better, but it's the size of it. If it's very small, if the minimum size is very small, then it means you need to go a bit closer and take a few more pictures, which might increase the process time. If they are very big, then you can be farther and be faster, right? So the trade-off is like how small it is, how fast you can go, but you can detect it in any case.
So yeah, kind of a rule of thumb is like if you can see it on the picture, then actually it's detectable by the system. And if it's big enough for a human to see it, then usually if the human can see the small dents or scratches on the metal sheets before the paint, then the system can actually detect them as well. Any other questions? Maybe something we didn't also cover here, like the system also works for plastics. I mean, plastic, metal, shiny surfaces, scratch dents, underfill, specifically for plastic injection molding. That's also use cases that are covered, specifically also big parts needing automation with robots. Very good setup.
There is also one that we didn't mention. It's about also detecting if the assembling is correct. If, for example, there's because it's not only about those defects, but you also can add another layer, right? Because you have 3D scanners, dimensional control, AI camera for defects, but also you can detect, for example, if there's supposed to be a cable, if there's supposed to be a hinge there, like if there's any part, anything that is missing, or like if the cable should do this shape and it's doing another shape, right? So the AI camera, the nice thing, I like to think about it as like maybe as a 10-year-old, you know, if you can tell a 10-year-old, okay, do you see the defect there, and he can see it, the AI camera can do it too, right? So it's like it's it is able to tell when things are right and wrong, not only on surface defects and things, but also, like I said, some cables, or there should be some hole here, but there should be a sticker. There should be readable text, but it's not readable. Like there's a ton of use cases.
So yeah, maybe to follow up on what Mark says, also to follow up on Joao's example of the car door, could actually flip the car and the door, sorry, and look at the harness of and all of the components that needs to be positioned in this car door. And it's also very good applications for exactly what Mark just said about, like, seeing if something is missing or not, or misplaced, which can be done actually with AI, and it's extremely easy to actually set up in the camera. Like, same as, like, yeah, teaching a 10 years old is like, hey, is this cable here or not? If it's not there, just please tell me.
All right, we have another question. Is it possible to now extract the rules laid out for AI and then fine-tune those rules manually? Like maybe AI finds some rules that humans fail to notice, but the threshold, confusion thresholds, etc., set by AI aren't satisfactory by human standards. So how much? So I would say, like, if I can rephrase it, how much can, and Lucas can help with that, how much can we fine-tune the results of the AI camera?
So maybe I can directly go on this. So I think that there are two things here that are important. There's the fine tuning, and there's also the understanding of what the actually the AI model is looking at to make his prediction about if there is a defect or not. So those two things are, I would say, like, working together, a bit separated. But to start with the understanding what the AI model is doing, um, there are actually tools that are specifically already integrated in the camera that let you kind of understand on what type of what part of the image the AI system is focusing on. So, for example, if, like, some defects are detected and you see that the focus is absolutely not on the defect but on something else, then here you have already information that the AI system is not focusing on the right thing to make this prediction. And so you can give more images or remove this part from the inspection region to really, like, focus it on the region you want to inspect. And then after, for the fine tuning, at the end, actually, the saying what is a pass or a fail is the responsibility of the human. So what the model is doing is that is going to do some it's going to do like a prediction or inference, saying, like, hey, I think this is a pass or a fail, but it's also going to give you a confidence score relative to this, like, how am I confident that this is actually true, what I'm telling you. In here, specifically on those ones, because specifically about this fine tuning is, like, also the bit of the outliers and the cases that are on a bit on the side. Here you can actually specifically design some rules based on this confidence score that actually let you kind of cover most of the use cases where there could be some confusion, and you want to actually do some very specific thing when this type of rare event happens, and then afterwards add those images back to the model to teach it to understand if this should be, like, 100% pass or 100% fail. I hope this answered the question, Neo.
If not, you can ask a follow-up on that. I just want to mention also that if you're using a robot with the AI camera, because we integrate the hardware, and I touch a bit the next question that we have from Mario, because we have this integration. You can, for example, take a picture in some place, apply some recipe that you've made in the AI camera about defects, and then move it, take another picture, and then apply a recipe about finding finding if the cables are correctly connected or if everything is there, right? So because we have this integration with our automation software, it allows for a lot of flexibility because you can move. And this touches a bit what Mario said, because he asked, can inspected defects or deviations be shown, Mark, on the CAD model as well? Would it be able to create a video out of the pictures as well? So the first thing, the good thing about having an automation software like ours, 11 Dynamics Automation Suite, is that it's a scene to real, right? So it's a digital twin, meaning that while we're moving the road in reality, we have that information in our software, and as you saw in some of the videos, it's scene to real, right? So it's basically doing the same. This means that if you take a picture in a position, we know where the position was taken, and we can tag it to the CAD, right? We can say, okay, this picture is here, right? And then from the pictures from the camera, we say, okay, I take a picture here. Here you need to apply the recipe. The recipe is how the camera calls the algorithm that should apply to that image, right? So it's like, okay, I take a picture here, apply the defect recipe, and then the automation software gets that result and says, okay, everything is okay, that's fine. Then it moves to another one, says, okay, this one with cabling recipe, because there's supposed to be some cabling here. I didn't find it. And then we can tag it on our simulation software. We can say, okay, actually the defect is in this part of the CAD, right? So that is something that is the benefit from integrating the robotics, because the robotic tells where you are, the AI camera and our automation software. And if it would be able to create a video out of the pictures as well, I'm not sure if you mean with like if the camera is able to record, or like if you can take a video out of the CAD with the tag defects as a video. If it's regarding the CAD with the defects in our automation software, we have some ways of taking continuous screenshots, and then you can assemble them as a video. That's what we use for marketing for our software. So maybe that's it. Video out of the AI camera. I'm not sure if you can clarify that. Maybe I can help you a bit better, Mario. The result is usually a picture with what you saw in the videos that we have, with some overlay paint, like, it's saying, okay, here's a defect, here's a defect. So that's usually the result. Is perfect. Are there more questions? Do you, Stefan or Nico, have any questions that you want to ask? Stefan and Nico are from 11 Dynamics, but maybe
not now. I think everything quite covered, quite good. Thank you.
Also from my side, thank you.
Stefan, you have experience with the camera as well, so you could even talk about it, how like the potential of the two together.
Yeah, I just have to mention we had a demo at the customer 2 weeks ago, Lucas and me, and I think it's quite incredible what is possible with the hardware, with the camera, how easy it is to set up. You also mentioned, Lucas, that you have to install 400 cameras right now. So it's even possible to do multiple camera setups. Yeah, it's crazy. Such
it's
a nice
actually
product.
800, but yes.
Sorry, 800. sorry.
Stefan, since yesterday. The day before was 400. So when we go to customers with Stefan, we also talk our solution, but we also talk of the solution of the AI camera, for example, in car manufacturers. And they're making big eyes, because a lot of car manufacturers are looking for solutions when they put the cars on the transport, on the trucks or on the trains. They want to check the cars before they go on the track, and check the cars before they go to the sales department, where people can buy the cars, that they can locate damage, errors that happens during the transportation. Yeah, this is a big topic in the automotive industry right now, but we have a solution and we are working on it.
Even to check if the car is fully the specs like ordered. Let's for example, are the right wheels mounted on the car before it goes to the dealership, and things like that. So it's such an powerful tool for visual inspection. It's crazy.
Where I also see a market is when you give back a leasing car. It normally checks, some people are checking the cars for damage. And my idea is that the AI camera can help at the process, that we have such an, for example, an AGV, which is going around the car with the AI camera and check the car for scratches or other things that can help for the process giving back a leasing car, yeah, which is not good for us because the camera is recognizing a lot of small errors. But I think this is also a big market we can go in, yeah.
So since Nico mentioned that, I want to just I think in the video you guys saw that in the automation you can put it in a robot. You can put it in a robot that is on an AGV. So for example, one use case that we have is like you can have you have an AGV, a robot, and the AI camera or the 3D metrology sensor, and you can have it moving around your factory, analyzing if there's defects. And for example, you could, if you have a manufacturing line that is semi-automated, and you know, okay, here that this should be clear, right? This should be clear when the part comes in. You can, move the robot there, take a picture, and say, is there anything? You train it with the good conditions, right? And then you say, okay, they shouldn't be here. And then if there's something, you could, with our automation software, you can say to the PLC on the line, you say, okay, you need to stop because there's something weird here, right? I don't know, the operator left a wrench in the middle of the of the line. It's going to cause problems, right? So it's, at the end, it's like I said, the visual example of having not a child, because you cannot have them working in a factory, but you have a person there checking the things and say, okay, that shouldn't be there, but you can have it moving around the factory, and you can train it to say, okay, now make sure that nothing is there. So the capabilities of the AI camera are like great for all these kind of examples where a human can detect it. And even if you cannot detect it, because they have a special lighting of photogrammetry, and then it can pop up some of the defects that even with the eye is very hard to see. You can put the robot there, and it creates a strong light, and then you are able to see things that not even with the naked eye you can see. But the concept is mostly naked eye things that you can detect. The AI camera can do also. Lucas, anything else you want to add, or?
No, I think it's what's very important, I think, to remember also for the participants here is that the ease of use of AI now, and specifically coupled with the ease of use of automation. So basically 11 Dynamics plus Vune makes like so many use cases accessible, that it also kind of like it's actually worth sitting down and thinking about, actually, hey, what are the things that we didn't think was possible, that are actually painful, that are costing us money, but that I know that we can actually solve.
Yeah. Yeah, we're also happy to explore that with any person that's here. Like if you have a use case, an example saying, I'm having this problem in the factory, I want to detect these things, but of course, as we discussed, that we haven't found a good solution. You can always shoot us an email, and we can analyze it. You can also send pictures saying, okay, is it, and then because Lucas is very experienced with a lot of use cases, he can tell, okay, this is possible. This should be easy with these things, with this setup. You would need this, and so we're very happy to provide with help and consulting you on all the potential problems that you think, this is a vision problem, and then we can tell you exactly how that would if it would work, how it would work. So usually on this proof of concept, the customer, what they do is they send a bunch of pictures saying, okay, these are the defects that I normally see. Can you detect those? and then we work from that. So we feel free to reach to us and send us those pictures or those questions. We will be happy to provide answers, and maybe even we have similar examples that we can already show. Yeah, we've done this here or there, right? So we're really happy to help you, because AI at the end is very general. So what we try to do is narrow it down here with with a few examples, but there's a lot of potential, right? So it's like on the camera works really well, and the potential is great. So even things that you thought, maybe I've been waiting for this for a long time. I think right now we are at the place where the technology can actually do it.
So thank you, Marc. I think there is not really nothing to add. I think we're gonna close this webinar. We will send out later on the recording of the webinar, or the link to the recording of the webinar, so you can forward it or share it within your company, or just spread it around. And if you, as Marc mentioned, if you have any questions, if you have a ongoing issue, just get in contact with us, send us an email, send us the request. We will catch up with you, and we are here to support you and find a solution for your problem, let's say. So thanks everyone to join and attend this webinar.
Thank you, everybody.
Have a good day.
Bye.
Bye.
Yeah.
Bye-bye.
Have a good day. Thank you. Goodbye.
Bye.